All right, everybody. I think it's time to get started. Hello? Hello? All right, it's time to get started, everybody. Can you hear me? Actually, okay. Okay, everybody, it's time to get started. So, welcome to the SQL hands-on session number 2. My name is Gavin Gray, and I will be helping with Johannes Rausch. There was already a question that was asked if we have links to the Katacoda or data sets for this week. The answer is no. I want all of you to be super focused and answering my questions, helping out right here. Basically, how I have intended this to work is you will be telling me what to type, and we are going to be solving all of the questions together in a very interactive format. So please do not hesitate to raise your hand or to just shout out if I mistype something of the sort. Okay, so to introduce you to our new data set, we are going to be working with a data set that models chess. So we have chess players, games, and like tournaments. So you can see here on the left side, this is kind of a small version of what we're going to be looking at. So we have our events at the top, and at an event there can be many different games. So for example, we have the World Championship here in 1987 is the year, and the event ID is, just a unique identifier for this specific event. We then have a table with all of our players, and we can see that players have names, and for the purpose of the picture, I put the names together, but we're going to have last names and first names be separate. They also have an ELO rating, which, if you're unfamiliar with chess, that kind of just says their current standing in relation to other chess players. And then we also have a player ID, which uniquely identifies each player. Lastly, we have games, and this is what is going to relate players to events. And there are many games which can be taken at a single event. So for example, you can see here, we have this event ID 3, which occurs twice. And then we have the player who played as white and the player who played as black. So we have this kind of double relation going this way. And then we have the result of the game, W for white winning, B for black winning, and D for a draw, which means nobody won and nobody lost. And that is the basic introduction to the data set. There's going to be a few more extra details that we add into and actually creating the tables. So let's go ahead and get started. I'm assuming that all of you know how to create a table at this point. So can anybody tell me if they wanted to make this players table, the types of columns and data types that you would have on it? I'll get it started. So we're going to do create table players. Cool. Nobody. Yes, right here.
We could use a name and then the type of variable character, so bar,
Yep.
some number, 20 or something.
Cool. I'm going to split it up into first name and last name, but yes, good type. Good idea. And you said we had a varchar, and it doesn't really matter what number we put in here. We just don't want to cut anybody's name off. We will assume that nobody has a name that's longer than 255 characters. And similarly for the last name, right there. I'll need a comma here. And we don't want anybody to have a non-existing name, so I am going to make both of these not null. Does anybody have objections to this? No? Okay. Is there anything else that we need in a player's table? Yes?
ELO, which is integer.
Yep. Okay. And anything else you'd like to add to that?
I don't know if there's a standard ELO that you had actually notified before.
I don't know what it starts at, but we're not going to be having that feature in here. I'll just add not null because you should have some rating. Anything else? What's the primary key of the table? And how do we add it? Yep, over here.
Again, just PID with integer, not null, and then also like primary key reference PID.
Okay. I'm just going to call it ID because that's my preference. And you said you wanted an integer and not null and anything else? Primary key? Okay, I'm going to add, I don't know if you have seen this syntax here. For adding a table attribute rather than a column attribute, I would prefer to do it that way. Is that something that they have showed you in the last SQL session? Maybe? No? Okay. I'm getting shakes that say no, so this is how I'm going to add the primary key onto this table. Basically, it's adding a table attribute rather than a column attribute. You can add primary keys as column attributes, in which case it would just come up here and we'd say primary key. When you start getting into real databases that have lots of columns and you also have lots of attributes and table attributes, it's easier to have all of the table attributes together at the bottom where everybody can read them nice in one place. So I'm going to just start that convention here, and we're going to add primary key down to the bottom. And then one other thing that's going to be kind of new, potentially, is we're going to make this a serial data type. Serial in Postgres just means if I don't give it to you, you're going to create a new one. So basically, we're going to be adding a bunch of players to the database, and we don't know what their ID is, but we're just going to have Postgres manage that ID for us. So it will create a new variable for us, a new serial value that identifies each player. Cool. So that is everything that we have for the players. Let's go ahead back onto the games here. Make sure it. Okay. Actually, let's do the event first. The event is the easier one. Okay. Thoughts on the events table? Anybody? If anybody on Zoom has an idea, just type it in the chat as well. Yes, right here. Perfect. Yep. Good. And we're going to just make it the same as before. And also, one thing, we don't actually have to specify not null for the ID because it's the primary key. And so by definition, you can't have a null primary key. So just one other thing. So we have the ID for the events now. We also have some sort of name, years, things that we need to add. Yes, here. Perfect. That's great. Okay. Right here again.
And then a year, which is an integer, and again not null.
Perfect. And I am going to just change it ever so slightly. This is one of the things is we are going to have dates rather than just years. And so that's the date type. And you said not null, which I agree with. And then lastly, we need to specify the primary key. And I will assume that all of you can just copy that from there. Okay, so last table, the games table, this slightly more complex one. Any thoughts? Anybody? Again? Yep.
We would need to make 3 different IDs.
Okay.
So we're going to EID, WPID, and BPID.
Okay.
I don't know if we pick serial for this also, or if it would be integer.
Mm-hmm.
Probably serial because we're going to match it with other IDs, I'm guessing.
Okay. So I'm going to just repeat that question so everybody can hear it. The question was, we need 3 IDs, an event ID, and then 2 for each player, or 1 for each player. And what data type do we make them? An integer or a serial data type? There's a hand right here. Okay. Yep, that is a good observation. So you're saying we need an ID for the game, and that's going to be serial, right? Is that what you were saying? Cool. Nice. And you were saying we need an event, so I'm going to just say, actually we'll call that EID, and you wanted it to be serial, and also you specified not null, and then we're going to call these white player, some type, and black player, not null. Okay. And so these types here, we're saying serial. Is that your argument over here, was that they should be serial? Not serial. Why not serial? Yes. Yes, correct. So if we put serial, we are allowing somebody to insert a row into the database without specifying a white or a black player, and then the database will auto-generate a key. And that's not entirely correct because that key would not exist or not necessarily exist in the players table. So then we have all of these keys getting generated for players that already had keys in the first place. So we are going to make these integers, and similarly, I am going to make the EID column also an integer for the same reason. We don't want an event to get auto-generated when it didn't exist in the first place. Okay, and then again, we will make the primary key the ID. Cool. And then one last thing to make our lives easier is on the players table. I don't want any 2 players. Oh, go ahead.
We need the result as well.
Yes, we do need the result.
Is the varchar of length 1?
We do need the result, and it is just going to be a char of length 1. And you said varchar, but I'm saying char. Do you know why I'm saying that?
Cannot be length 0.
Exactly. That's exactly correct. We always want it to be 1 character. It needs to be either a D, a W, or a B. And we always want 1 character. We don't want fewer than that. So we will just add result in there. And we also want it to be not null. And then what I was saying before, to make our lives easier, we are going to make sure that no 2 players have the same name. This will simplify our queries a lot. And you can add that with a unique constraint. And then you give it a tuple of columns, and then the database will always make sure that that tuple is unique, right? This isn't like a primary key, it's just a unique key. And so we say first name, comma, last name, there. So we have these 3 things. Okay, I don't think we are missing anything. One more thing that I'm going to add in here. Actually, I'll just show you. And we want tiny chess. Okay. 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 We're being recorded now, just so you know. Go ahead. Sorry, could you repeat that a little louder?
Shouldn't it be create table events?
Yes, it should. That is just me forgetting to type all the words. Yes.
We also introduce some foreign key constraints in the table.
Perfect. You are jumping ahead, but that is exactly what we want, right? And we will get there in 2 minutes. Okay, so now in this table, I already have these tables pre-made, and we can just see, for example, that in the players table, we have our ID, which is, Postgres is going to convert serial into an integer data type, but then have this default value, which creates a sequence of integers. So basically, it'll just increment the integer each time. Then we have the first name, which is the varchar, which is exactly what we put over here. We have the last name, and then the elo here. And then we also have this primary key, which is on the ID column. And then the unique constraint, which is what we typed here, and that is on the first name, last name. So the tuple of the first name and the last name. And then we can do the same thing for events and games. And these are the exact same things that we typed over here. The one thing that I introduced in the games is there's a round, and this is just to be more precise to the chess world. There's different rounds within games, and then there's also a set of moves. So they record all the moves made by the players, and so we have those as well. But then everything else is the same. We have the white player and the black player, which are integers. We have the event ID, which is an integer, and then we have our ID for the games, which is just this incrementing serial value. Cool. So we have all of those ready, and now you are all experts on how this database is laid out and how the schemas work together. So let's start making queries. And the first one is I want to find the names of any player with an ELO rating of 2,500 or above. Can anybody tell me how to get that? And I want this in one column called name instead of first name, last name. Anybody? This should be a review from last week, I'm hoping. Yes, right here. Just first name? Okay. So now if we run that, it's going, there we go. So we have these 3 rows here, but we only have the first name of people, and I also want the last name with the first name. My idea was that they have their full name represented, but just as one name. So how can we do that? Yes, up here. Okay. Okay, I think that's where you were headed. And so now we can do this. And there we go. So now we have the full names of these 3 players. And in fact, we can make sure, so if we do this, we can actually check that these 3 players have an ELO rating of 2,500 or above. So we have this first one here, 2534, and then, yep, we can keep going there, and we can see that those 3 have 2,500 or above, and everybody else is excluded. Perfect. Check. Nice. And just a heads up, so the database that we have currently is really small, so we can actually sit and look at the output, but in a few queries, we're going to move to a database which has hundreds of thousands of rows in it, and so we actually are going to learn how to write queries without being able to inspect the output manually, which is kind of a nice skill to have when you're working with real data sets. Nice. So the second question here, we want the names of any player who has played a game as white. So this is, they've played a game as white. We don't care about the outcome, they've just have played as white. Anybody? Yep, right here.
So we select the name thing from above.
Okay.
First name, command line, last name.
We can just separate them, okay?
From players, join the games on, or players P join games G, where P.id equals G
said where? Okay, it's on, okay. And so we're saying p dot
p.id equals p.whitePlayer.
white player. Does anybody disagree? Or does everybody agree? Head shaking? No? Okay, so we can run that. And we have 6 rows here. And we can inspect these, so let's just copy that over here. Yes, so good catch. So we have James E. has played twice as the white player. And we actually just want to count distinct players. So now if we come back here, we have 5 rows. Each name is unique. That is exactly correct. Okay, second to last of the hopefully review queries, we want all of the names of the players who have won a game as white. So the last one was if they had played as white, now we want them to have won as the white player. Thoughts? We can start from this query, which got us all the white players. Yep, here in the... Like that? Okay. And that is correct. So we have James E. and I'm not going to pronounce, there's a 1 in the name somewhere, Gregor. So those 2 players have won as white. Perfect. Nice. Now we're going to come back to your question of we have the events and we have games, and the game has 2 players in it, but how do we know that the players in that ID column exist? And we can kind of, simulate this by inserting a row into the games table with 2 players that don't exist in the players table. Does anybody have an idea of how we can do that? I'll start it with the insert keyword. I'll give you one more hint, okay? Nothing. Yep, here.
I'm not sure, but to insert into games,
Mm-hmm.
when we do bracket, we write the tuple out.
Okay, what is the tuple that we want? I guess we can look at the schema while we write it, right? So we need some sort of round, a result, moves, black player, and the white player. Okay.
And to find a non-existent player, I was thinking we could take the max player ID
Mm-hmm.
and add 1.
Cool. So how do we find the max player ID?
Should that be max players.id?
So we would need a full query, right, to actually go and get it? Okay.
Select max players ID from players. Or, yeah, that works, yeah.
Okay. And then we would need to actually increment it, right? And then we're going to do that same thing, but we are going to increment it twice, just to make sure that we have one that doesn't exist. And then we also need, I'm just forgetting it now, an EID. And let's just do the same thing with the EID. There we go. Does anybody think this won't work? Here, yes.
We need another ID. We need the EID and the normal ID.
So we have the EID here, right? And that's this one, the events. So if you remember, we made it serial for this reason, right? So we don't actually have to specify it. So if we go ahead and run this, we have a syntax error somewhere because I included an extra comma. And now we inserted it into the table. And this is terrible because neither of those players exist, right? We can just do a select star from games. And then we can do a select, I guess it's better to do white player, black player. And then select star from players. Right, so we can see that 12 and 11 don't exist in our players table. And this is bad because we now have a game which was played by two non-existing players. Go ahead.
I was wondering, how were we able to insert that in the table if we specifically said result should not be var char, but just only char length 1?
That is a really good question. I forgot to put a character in there, but it seems that it did work. So let's actually see what it included as the result. Empty. Okay. So my knowledge of Postgres and how it, handles those types, maybe I lied to you a little bit. In theory, this should not have entered. I wonder if it is the single character. It might have just done a space. I don't know. I would have to look online and read something and then tell you why that happened. That's my fault. I was supposed to put a character in there. Okay, so this gentleman over here earlier recommended that we add constraints to the events table that ensured that we had the players getting inserted in correctly. So can anybody, besides you, because you know what we should do, does anybody know how we can enforce that rule on the tables that we have up here? So we'll come back here to the top. And we want the games table. Okay. There was a half hand over there. Nobody? Okay, I will let, do you have an idea of how to do it? Yeah. Okay. Yep, so that's exactly correct. So he said we need to specify an attribute in the games table that corresponds to an attribute in the table that we're referencing. So in this case, it would be white player references players of ID. And then we're going to do the exact same thing for the black player. And then we also need to do the same thing for the EID, which references events ID, just like that. So that would be the syntax there. So this is saying that we have a constraint on the white player that when it's inserted into the table, it has to reference a key in the player's table. And so now if we created this modified table with the foreign key constraint and tried to insert this new value, it's actually not going to work, because it's going to say that the foreign key constraint was broken and that player doesn't exist, essentially. And this is really important basically when you have any tables that reference another table and you want to make sure that there's actually a correlation, a relation between the two things. We want to introduce a foreign key constraint to withhold the integrity of the data in our database. It would be really unfortunate if someone came into this table now on the left, where we have two non-existing players in the games table, and they tried to do joins. I mean, it would just exclude the column, but we have these games that nobody essentially played in. All right. So, as you all saw here on the left, this database is kind of corrupt, so I'm going to switch to a new database which I call chess. Yes, there's a question up here.
When does this constraint get checked for? Does it only do an insert or even delete players?
So the constraint is going to get checked whenever you have, data modifying it. It's a constraint that always exists between these two columns. So if, for example, you tried to update a row that already exists, and you tried to update it to a player ID that doesn't exist, it would reject the update, saying that this player doesn't exist. Similarly for inserts. Yes, right here.
How are circular dependencies handled? Say I have, for example, parent-child, two different tables, and the parent references its child, the child references its parent as a foreign key.
Good question.
Insert one. Can I do a batch insert?
Good question. So the question was, how do we have circular references between two tables? And in Postgres, I'm not 100% sure how this is handled. I can tell you that in my SQL, which has a lot of similarities, you can't have a circular reference. You can put it on the tables, but you would actually not be able to insert anything into either table because it doesn't exist. So you would have to break the dependency somehow. So you would either have to not have the foreign key constraint, insert all of your data, and then add it later, which is, in my opinion, not super recommended, or you just organize your data slightly differently so they have one base table somewhere and then they can reference it in a tree fashion. Yes, that's a great question. Over here. So could you repeat that? Sorry, I didn't hear that. Yes. Yes, that is a good observation. And the answer is we are not going to handle that here. We are just going to allow a player to play against themselves. Maybe they're lonely and don't have anybody to play with, but that's much harder to enforce, that they can't play themselves. So we're just going to ignore that for right now. Any other questions? Yes, here?
What happens if we delete a player and then we have a reference to a player that doesn't exist in the beginning?
Good question. So currently, in just the tables, where is it, right here, we could not delete a player if there existed a game that referenced it. What we can do is you can say like on delete, and then you can say like do nothing. I guess, I don't know if that's the right syntax. Basically, you specify what should happen. You can also specify that the events get deleted. Most of the time, you just disallow the deletion and just say, okay, this player exists, and this event references that player, so you can't delete the player until the event no longer exists, or the game no longer exists, excuse me. But yes, you can specify how it should handle those cases. Any further questions before we move on? No? Anything in Zoom? No? All right. So now it's important to just look at how many players we have. That's not good. Did I go to chess? I did, right? From games. Okay, interesting. Okay, there we go. So we have roughly 20,000 players, and above you can see that we have 235,000 games. And so if we ever do a select star from players, first of all, it's probably going to crash my editor because it's just a lot of rows to handle. And second, you're not really going to be able to read the output. So we now need to be able to work and reason about our queries without actually inspecting them manually. Like I said before, this is a really good skill to have when working with real data sets. Oftentimes you have millions and millions of rows, so you can't actually print anything or look at it other than reasoning about the schemas and how the relations work. So we're going to start working with that. So first, let's find the names of any player who played any game in 2018. So how could we start that query? Right, so before we got the names of all players who had ever played as white, and now we want any player who's played any game in 2018. Any idea of how to start? Yes, right here.
We can again join players and games.
Okay.
Players P.
Players P, join games, okay.
Games G, for example, on again the ID, so white D.ID and G.whiteplayer.id, or P.ID equals P.blackplayer.
Okay.
Then we want to filter by year, so we have to say where
Okay.
dot date, and now we need to do the date component syntax where we only extract the year. I'm not exactly sure how that is.
Yep, okay, that's totally fine. I find the syntax personally a little strange, and I wrote it down just for this reason. So basically we have to say extract, and then we want the year from event date, and we said we want this to be 2018, right?
Yes, and now we need to select the information we want.
Okay.
First name, last name, and again we need to make it distinct because we don't want duplicates.
Perfect, okay. So we could, in theory, right, run this, and like I said, it's going to probably, I have a typo, from, we have another typo, event date does not exist. What did we call it?
So we have to join games with event here and here.
Yes, correct. Okay, so we don't have a date in the games table. We only have a date in the event table. So now how can we add that into the mix? Just join it again. So we have players, join games, join events, E, on, we'll make this a new line. And what's our specification there? And yep, so event ID is equal to the game EID, is what we called that there. Cool. And so now we have e.event date is equal to 2018. And we'll go ahead and add this in there. Near where I have another potential syntax error. Again. Okay. Does anybody have an idea of what's wrong? I know how I would fix it, but that might be a lazy way of fixing the problem. I can also make that a little easier to read. Yes, up here. Okay, so you're saying here we're going to say on something, and then we're going to join on the other one. Okay, that is an idea. I don't know if that would work or not. It seems reasonable. I will just go ahead and tell you my lazy way of doing this would to just be to do cross joins on both of these, and then we are going to actually bring this into the where clause with the other ones, right? So we're going to have two cross joins, players, games, and events, and then we're going to extract the date here. We're going to do these and then include that there. Get rid of that. And then I think, if I remember correctly, this worked. And you can see that that's going to run forever, so we'll stop that. So now, instead of selecting the first name and last name, we can just select the count. I mean, that doesn't guarantee that what you wrote is correct. Does anybody have an argument as to why this query works? No? You can ignore this number. I did it on a different database. Yes?
Joins are always a subset of cross joins.
Okay.
And by using Boolean syntax, we basically just do the same effect.
Yep, exactly. And then we're constraining it by the year. I mean, I think that's fairly obvious. That's what we wanted. We also are saying that the player ID has to be the white player or the black player, right? So we're constraining the two rows in a tuple that get joined together. We're constraining it by the players that exist onto the white player and the black player. And then we have our last, which is the game ID or the event ID in games is equal to the event ID in the events table. Yes, up here.
How does this distinct exactly work? Does it get applied before the count, or does it not count the players?
So distinct doesn't make a ton of sense how I've written it here. If we wanted to, we could go back to the first name, last name, putting distinct here, and then we would make this a subquery. And then we would say select count star from this subquery. I believe we'll have to name it. And now if we do that, we actually do get the right answer because we're getting distinct values. Correct.
Distinct always compares all values. Do you have a choice how we can say, okay, we want to be
So distinct works on all of the values that you project out of the relation. So because we had first name, comma, last name, it's going to just do distinct tuples of that sort. If we had more names, or like more columns, let's say we also projected out the ID and maybe their favorite food, it would also make a distinct on that entire row. Yes. Okay. Are there any questions? Did I confuse anybody? All right. Let's go ahead and move on. So now we want the names and the dates of any event in which Magnus Carlsen lost a game. So we can actually, let's just select star from players where first name is equal to Magnus and last name is equal to Carlsen. This is just to show you that this player exists. Okay. So this player is in our players table, he exists, and now we want the names and the dates of any event in which he lost a game. Right? So which tables are we going to have to join together? I guess that's a good first step. Have hand up here, yes?
We could take the subquery from the previous one, but remove the extract.
Okay, so you're saying we take that down here. And we're removing this.
And then add the additional thing where, after that part, P dot first name equals Magnus, P dot last name equals Carlsen. And then I think we would have to do P dot ID equals G dot white player and result equals B.
Okay.
And then before P dot ID equals G dot black player and result equals W.
Okay. So your suggestion is to make this where clause like ginormous as long as we can possibly make it and just add all these conditions. That would work. Does anybody have a different way of how we could maybe rewrite this query to use different operations, maybe different inner subqueries that would make it potentially easier to read? Not that this wouldn't work, Just want to see if anybody has an idea of how we could write it differently. I can give you, yes, right here.
We can see on the left that the ID of Magnus Carlsen is 231.
Okay.
We could use that on a join between games and events.
Okay.
Then just check if the player doesn't with white ID
Mhm.
is 231 and black one, or
Yep.
where.
So the suggestion is to just use the player ID, which is it would work again, but we're going to try and reduce the amount of information we know about the database. So for example, if I now switch to a different database where Magnus Carlsen had a different player ID, we would want the query to still work. But also a good, valid suggestion. This is in the way. Yes, up here.
Well, if we know his name,
Okay.
we can also directly find the player ID and then go.
Okay. So you're saying we get his player ID from the players table. So how would we write that?
You would select the ID from the players table
Okay.
where first name was Magnus and last name Carlsen.
Okay. So now we're able to get his ID. Perfect. Thank you. And we can see that it's 231, which we're not going to use in our query, but we can use this subquery now in our other queries. Yes, go ahead.
I don't know where we would put it, but we could put that in brackets and write as something ID.
Yep. A fancy syntax for that is we can say with, we select this thing, and then we can say as, we'll say Magnus Carlsen ID. And we're also going to split this a little bit to make it a little more readable. Perfect. So now, we have his ID, and it's called MC ID for Magnus Carlsen ID. Now how can we use that with other queries to get the data that we're looking for? Any ideas? So the first thing, I can give you a hint, the first thing to observe is that Magnus Carlsen can play as white or as black, right? And that's what you said earlier. So maybe we can start by just selecting something from where he played as one of those players. Anybody? Any ideas? Yes, right here.
Just select games where we played from the games table.
Okay.
Where he's white or black, and then we just just do with another with, and then mark it as unknown played or something.
Okay.
So we can cross-join those.
So we would do here, and you're saying, so what would the inner query be?
Just select from the games where white player or is Magnus Carlsen or his ID, the MC ID, and then or black player is MC ID.
Or black players, MCID. Okay, so this gives us the list of games where he played as either the white player or the black player. Perfect. And we'll call this games Magnus Carlsen. I guess I can put those here. Okay, so now we have the games in which he played. Now, how can we get the name and the date of the events that those games were held? Yes, right here.
If we put in the three dots, the ellipses, I guess.
Yep.
If we put EID there,
Okay.
then we can join that, or join GGS with events,
Okay.
and select, we say name and date from 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 events join GGS on. Oh, they don't need to say on it. GGS is just
Sorry, it should be Magnus Carlsen. Join that on.
EID or ID equals events E, and then have E dot ID equals EID.
Something like that. Okay. Any objections, clarifications? Yes?
I think that's just all events where Magnus Carlsen played.
Yep.
So we would have to check where white player is equal to empty ID and the winner is black.
Yes, correct. Did everybody hear that? So this query, as it is going to select all of the games in which Magnus Carlsen played, but we wanted the games or the events where he lost a game. So basically, this query GMC, which represents all the games he played in, we really want that to be all the games that he played and lost in. And so the suggestion was to say, well, the white player is equal to this, but we also want the result to be equal to black, meaning that he played as the white player and lost. And then this one is he played as the black player, and the result is white. So he lost that way as well. Okay, so I agree with the rewrite, thank you. Any other corrections? Yes, up here. Okay. Yep, correct. Because multiple games can happen at one event, so we want just the distinct events and dates of those. Correct. Anything else? Yes, up here. Could you repeat that? Sorry. Yes, there is. Okay. Thank you. Yes, we are. This is why you guys are here correcting everything I typed. Nice. Anything else? Should we run it, see if it actually works? Oh, I actually flipped the syntax here, so we say with that as, and then we also do a GMC as here. We'll come down here like this. Okay. You're saying we were missing another bracket somewhere here. You think now it's good? Perhaps you meant to reference that column. It's possible. Okay, somewhere I have a syntax error, but this is the right idea though. So that's the important thing of structuring the query. The right idea is selecting, yes, up here. This line. Is it a comma? I don't think. I don't think a comma there would help, but maybe in the break I will rewrite this and I will show you the correct form of it and where we went wrong. But this is the good thing, is to structure this query of, getting the subqueries, what we want, and then selecting what we need out of the join of those subqueries. So that's kind of the good process that we're looking for. Any other comments or questions about this one? Sorry that it was kind of vague. Yes.
It might be like small, but trying from games cross join and
from games, you're saying cross
There in the with statement.
here in this statement?
Yeah.
There? Where? I don't.
Games, cross-join, MCID. Right, just the start of that line.
Oh, so you're saying we cross join with MCID. And then we say where. Yes, that's actually potentially the thing. There we go. Any thoughts on this? You can also ignore this number. This again is potentially wrong. So I can revisit this in the break and show, maybe a different form or what we have going wrong here, but that's the main idea. So let's move on to the next query and use that same sort of process to get the results that we're looking for. So the next thing is we want the players with the top 15 ELO ratings. This one's a little bit easier. And we want to sort the ties in alphabetical order on the last name. Should we take a pause now? Okay. Johannes is saying we should take a break, so let's... oh, yes, we definitely should take a break. Let's take maybe just like a 5 to 10 minute break so we can get to some of the later queries. So we'll come back here at, let's say, 15:20. Right. All right, everybody, let's go ahead and start again. Sorry for the short break. But let's go ahead and get started again. So just to revisit the last query that we were writing, I believe that it's correct. But I will, double check it, and then I will be posting this interactive script along with the data on Moodle, and then I will post several different queries and that they are all correct in the script. So you can look at that later. Okay, so let's now start on towards some of the more complex queries and hopefully new and interesting queries to look at. So the first one, as mentioned before the break, we want to find the players with the top 15 ELO ratings, and we want to sort ties by the player's last name alphabetically. Okay, so does anybody have an idea of how we would go about starting this? Yes, right here.
I'm not sure how the question has been interpreted. Does the top 50 year ratings mean the top 50 players or the top 15 year ratings?
Good question. Top as in the highest. So they should have the highest 15 ELO ratings. So the 15 players with the highest ELO rating that we have. Yes, I can rewrite the question to make it more specific. Okay. Does that make sense? Does everybody understand what we're looking for at least? Yes, back here. I'll just leave it like this for simplicity, but yes, that's correct. Okay. Okay. Last name what? Ascending. Good. Limit 15. Nice. lame name does not exist. That is correct. There are no lame names. We just have last names. Cool. Have you seen the order by keyword before? Is that something that people are comfortable with using? Does this query make sense to everybody? Is it correct? Does anybody disagree? No? Okay. Then I will move on if there are no questions. So the next query now is we want to find all of the players who share a last name. So how might we go about starting this? So 2 players, they have a different first name, but they have the same last name. Yes? Sorry, what was that? Are you talking about here? Sorry, I'm not understanding the... So it should be in alphabetical order if 2 players have the same ELO rating. So we first specified, so the order in which we specify them determines the precedence. So we first specified that the ELO rating is descending. So we can see now, this here. So we have Magnus Carlsen at the top, and then everybody else, their ELO rating is descending. This isn't super helpful because I don't think there is a duplicate here. So we have these 2 last names here, and D comes before N in the alphabet. So they are that way. If we rewrote this query to also use descending, we can see that those are now switched. So we can see that precedence there. Perfect. And then if we switched ELO and last name in the list, it would give us the players whose name started with Z or something, and then the rating is a second attribute there. Cool. Any further comments or questions about how to use order by? This is a fairly handy tool. All right, so now we want to find all the players who share a last name. How could we start going about this query? Yes? Okay. Okay, so you're saying we do a Cartesian product of players with players, and we check that the last name is equal, and that then the first name is different, or the player ID is different, right? So it's not the same person, but they have the same last name. That is a good idea. However, it's going to give us the names all separate, right? So if you had someone with the last name like Müller, you would have, all of the Müllers together, but they are all on separate rows. And maybe this was not specific or not specified here, but we actually want them to be collapsed into one row, and later we're going to count how many share that same name. Yes, right here.
Can we use group by?
Yes, we can use group by. So how would you use group by?
Select star from players, group by last name.
Group by last name. Just like that. Anything here?
What do we need to, do we only want to output the first name or what is asked?
So I haven't really specified anything. We're going to change the question actually right now. So we can run this if we wanted to. And we can't select star. Let's select the last name here. Okay, so those still running. Shouldn't take too long. Maybe. Okay. So those are theoretically the lists of people who share the last name. But what about people who have a distinct last name? Right? So they are in a group of 1. what if we don't want them in our set? We only want people who share a name. So how can we specify that we want this to be greater than 1, this count? Yes, right here. I'll put that there, yeah.
That constraint having counts or greater or
Cool. And why is it having and not where?
because having is for the aggregate functions for the groups and where is for the individual records.
Yes, exactly. So if we used where, it actually would work on the table before grouping. So your answer was correct, that having works on the aggregate functions with the groups and where works on singular tuples. So now if we run this, we're going to get hopefully a slightly shorter list. Maybe, yes, okay. So 22, 32 rows, and now we can see that we have these people with 11s and 2s. How can we sort this by people? So we want to sort it by groups that have the most to the least. How can we then do that? Yeah, yes, right here.
Order by, I guess if we give the count attribute a name, we can do order by that.
So you're saying as, we'll say C?
Order by C descending.
Descending. There we go, 2s, and then we get no groups with 1. Perfect, that's exactly what we wanted. Nice. Does everybody understand order by, group by? Are there any general questions about how to use those? Yes, up here.
Does it matter which order we place these keywords, like having or order by?
I think yes, but why don't we just try it? So is SQL going to complain? Yes, having is a problem. So generally you have, when you have the list of kind of selectors or conditions at the bottom, they nest together. So you have this group by and then having directly after it, where if we have this order by, it doesn't really make sense with the groups, because order by doesn't work that way. So we need to have the having first and then the order by second. Does that kind of make sense? Any other questions? Oh, okay. So let's go ahead and start on some of the last ones. So we want to find the names of all the opponents of Magnus Carlsen. So earlier we found the game or the events in which Magnus Carlsen had lost. So we did something similar. Now we want to find the names of all of his opponents. How might we start this? Any ideas? Yep, here again.
We can do with again to find out the MCID.
Okay. So we're going to play the same trick as before, right? So we're going to select, okay. So we'll just select, I could just get it from above, but we'll type it where first name is equal to Magnus and last name is equal to Carlsen. Nice. Okay, so that gives us his PID. Now what else do we need?
Then we do select first name, last name.
Okay, so select name, comma, last name.
From players join games, join players.
Players join.
Players, wait, we do it twice. We can probably do it just players join games.
Okay.
For easier. On
Okay, so this is the player's ID is equal to,
James dot white player and James dot black player equals MCID.
okay, so games dot black player is equal to MCID.
So we need an and there instead of an or.
Yes.
Then we do or and just the opposite.
Sorry, I'm just gonna tidy that up. Okay. So you said now we do an or, so I'm gonna wrap this in a clause here, and we want this to be the opposite. So we have black player, and then here we have white player. And I believe before we had MCID, which was a table, right? I actually want this one. I think if we do that, it should work as a singular value.
And then probably select distinct also.
Sorry, I missed that.
Select distinct.
Select distinct. Okay, so we have select distinct first name, last name from players join games. On, similarly before, we have the ID, the white player, and the games dot black player, and then I'm missing an or there, but everything else sounds good to me. Does anybody have any comments or objections? No? Should we try running it? Okay, I'm missing an as there. I have a comma there. Okay. It seems that my
Players join games, join MCID.
yeah. And then this is dot ID. Another syntax error. It would be nice if there was a TA that could type, right? Where is the semicolon? No? Okay, I guess we can try adding it. Ideas? I need one more bracket, is that what you're saying? Okay, so we do this there. Nope, still not. I'm missing. Does anybody have an idea? If not, I can just rewrite it in a different way, but that's less fun. Nothing? No? For me, the easiest rewrite is always to have a cross join with Postgres because I don't have as much experience with it. There we go. Sweet. So we can talk later about maybe why the join on didn't work and the cross join where does work, but right, we again had the idea correct. Right, we did the steps, we got the inner query, and then we joined them how we wanted to. That's nice. One thing to note is we have been doing this with MCID as, and then we select, from Magnus Carlsen. We could also, if we really wanted to, just include that down here of saying the player's first name and last name is Magnus Carlsen. And that's also fine. The real benefit of having this with at the beginning is if we have an inner query that we use several times. So maybe we need its results in a few places. Giving it a name is very beneficial rather than having to include it in multiple places. Similar in programming, when you have a constant number that you use everywhere, it's nice to give it a name and use the name rather than just the number. Yes, up here. Yes, that is correct. So that's a good statement. So we have to check for the black player, and then we also have to check the opposite direction of the white player, which is a good segue to my next question, which is how can we rewrite this query using a union rather than how we have it currently specified? Make sure I save enough time. Okay. No? I can just give you kind of the outline, basically, just because we're running out of time a little bit, but we have these games white player. So basically we would just join, or we would find all of the games in which Magnus played as white, and then we would find all the games where Magnus played as black, and then just union those together. And that is essentially taking this big where clause and just breaking it into two subqueries and then unioning them together. So it's the same thing. And depending on the database engine in the back, these might end up being the same query, just depends on your relations. Are there any questions before we move on? Anything else? No? Okay. So the next question. We want to find the names of all the players who have never lost a game. And in this case, we're considering that a draw is not a loss. Also not a win, but we just won't handle that case specifically. So how can we go ahead and start this? Any thoughts? Yes, over here. Okay, so you're saying we take all of the players, just the entire set, and then we take a difference of the players who have lost some game. Yes, right? So we select all of the players who have lost a game, and then we can just subtract that from all of the players in general. That would work. Similar to all of these queries, there's about 10 different ways you can write them. That is one great option. Should we go ahead and do that? Set difference. Trying to remember if there's an operator for it in Postgres. I'm not in. Is it? Okay. Oh, yes, right. Okay. So let's go ahead and try that. Yes, up here. That is a good question. So the players in here, have they played in at least one game? And the answer to that is, I know the answer, but I shouldn't. Really, the answer is no. Right? We can have players who maybe have just registered, but then they've never played in a game. So if we excluded them, or if we kept them in our set, we would say, hey, these guys have never lost a game, which is true. They have never lost a game. They've also never played in a game. So it just depends on how you word the question, right? And with how I've worded the question, it was ambiguous, and I haven't specified that. But maybe let's make it more specific and say, of the players who have played in a game, choose those that have never lost. Okay. So now, given our new specification of the question, are there any thoughts? And this is a particularly good question because when you're joining the tables, you should always ask what it means, right? And in this case, we don't know necessarily that players have not. And so we need to kind of refine our specification and refine the question and the data we're looking for, which is a very useful skill to have. Yes, up here.
So in that case, we could call it with join with all players in the game. Okay. And select only those. I mean, yeah, we could cross and cross if that's it. Then we need to select for all for the same ID.
So you're saying we're going to take the players and we're going to cross join it onto games, and we want to select
Only the unique one.
all of the distinct ones. Okay. So that just gives us all the players who have played in a game. Is that your idea? Okay. So I'm just going to add P here and G there. White player or P.id equals G dot black player. Okay. Is that what you were talking about? There? Okay. So now we have a set of all the players who have played in a game. And the idea from before was to take that set and subtract all of the players who have lost at least once. So how can we do that? Maybe we can just say with all, just to give these a name and kind of do that here. And then we're going to say maybe losers, some other query. Okay, so how can we find all of the people who have lost a game? Yep, up here.
Basically the same, but we add PID equals G.whitePlayer and result equals B,
Mm-hmm.
and then the opposite for the other one.
Yep, correct. Okay, so you're saying we're going to take this, which I could note that if we had written the query above slightly differently, we could actually use the result, but it's not important. We'll just keep going like this, because that was me writing it. So we're selecting here, and we're saying PID is equal to the white player, but now we want the result to be equal to black. So we're saying this person lost. And then we're going to do that here. And the same thing is going to happen here. And result is equal to white. Okay, so that gives us the PIDs of people who played in a game and they lost. So now, how do we take these two sets, essentially, of PIDs and get the difference from them? And then also we wanted the names of the players, right? So we'll have to get the names from somewhere. Anybody? Yes, up here.
Sorry, could you write and result equals y or left in the query before? So we define all. So we have on line 4, like for up.
Yes.
Yeah, could you write where PID equals G white player and result equals y?
So that would give us all of the winners, right?
Yeah.
So if they played as white and then they won, and then, or if they played as black and won. So that would give us people who have won any game, but what we wanted is people who have never lost a game, right? So if we selected these people, it would just be people who have won a game, but they could have also lost a game. And so we need to really do the exclusion of them. Okay, so yep, over here. Sorry, which relation are we renaming? We'll just call it A. We'll do A and L to keep it simple. You said A except L? So I agree, except we don't have first name or last name in either A or L. So some point we need to get back to the players. Okay, so we're saying E as, we'll need another comma. Oh, that's a big comma. We're saying these here. And then we could. Yep. Okay. Make sure. Does anybody disagree with anything written? So we again have a syntax error. And so here we actually need to select, right? We can't just do A except L. We are going to need to do select ID from that relation, I think. Yes. I think we actually could. So should we try that? Would you prefer that? Okay, we'll try it. And then we'll just comment that out. Get rid of our comma. So we're doing A except L, and then join players using ID. And the hypothesis is that that is going to work. False hypothesis, okay. We go back to this. Is that going to work? Nope. Oh, because I do need these here. No, it's not liking accept, yes.
I think we might have to use select star from A brackets, except select star from L brackets.
Okay. I'm not entirely familiar with accept, so we might have to try. So you're saying we're going to do select star from A.
Yeah, so keep the thing we had before, and in the brackets where it said except, we have to do this, yeah.
Like that. Is that what you're suggesting?
I think we might need to put another select around that, is what I'm not sure about.
And then we're saying select star from that. If this definitely isn't the easiest way to write it, I'll just tell you that right now. From must have an alias. Yes, that's correct. There's no point in aliasing these because there's definitely an easier way to write this, I promise you. It's not that hard. Yes? Yeah, so that's a good question. What if we selected something else? So are you suggesting also selecting, for example, the first name and the last name? That is a good suggestion. I was just typing what I heard, and I thought I heard PID, or player ID, sorry. But would you like to try selecting those? Yes, worth it? I'm going to scroll up a little bit. So we're here, so we're saying P dot first name, comma, P dot last name here, and we'll add those. Okay. Yes, up here. Yes. Yes, that is what my next suggestion was going to be. So the suggestion was to take, instead of using with A and then L, we are just going to remove this here. And let's give myself some room here. So we have this. And we will have to give that some alias down here. And then the suggestion was also to take this here, and we say accept. So the question is now, like, do we want to keep the first name and last name in the projection, or in the selection of the two inner queries, or do we want to just use PID and then join it onto the players table later? So let's do that.
Can we remove the PID and don't make a selection? Can we just leave the first and last name?
And so there's one reason why we can do this. Do you remember why we can do this?
Those should be unique.
Exactly, yes. So we specified on the table that the first name and the last name are unique as a tuple. And so we don't really need the PID here because we have that unique constraint. So we could, in theory, just remove these from here. We'll do an accept there. We'll get rid of some of that garbage. And we get rid of that. Is there anything else anybody would like to add or object to? We can try running this. I'm sure there's some syntax error somewhere. Yes, okay. I can fix this later as well and post it. I do need the from. So you're saying just removing the first line. I don't think we can do that because we need to create a relation and select from it.
I think I saw it once with the example as it's just two relations.
Would it? I personally wouldn't be able to tell you off the top of my head. I would have to look it up, but we can try both because why not? So the suggestion was just to do that here. This is giving me an error now. There we go. Maybe it will finish. We're on the S's, T's, V. Okay, there we go. Yes, so that's correct. So apparently you can use accept without doing a select from it. Good to know. Anything else anybody would like to ask a question about? Or we can move on to the last query if we have 3 minutes, might not be enough time. So are there any questions about these or anything else that we covered today? Nothing. Okay. So for this interactive script, this will be posted onto Moodle, and there might be also some comparisons of queries that I wrote, of maybe you can rewrite these in a different way. The data set, I believe, should also be uploaded. Potentially, it might be too large, so I'm not going to promise that, but the script will definitely be online for you to look at. There are also different chapters of, in the chapters, there are the example queries on the different data set using the employees, and those also have good things which just mirror what we did here. So if there are no further questions, I will say thank you, and I'll stay around for a few minutes.